So in this problem, we're looking at multiplying rational expressions. Ultimately, what it comes down to is the same thing as when we're multiplying fractions. You multiply across the top, multiply across the bottom. So you multiply numerators, and then you multiply denominators. And then you can cancel any like factors in the numerator and denominator. And how we get to those like factors is that we have to factor everything that we can in both terms. So if we look at our first term in our multiplication, we have 5x over x squared plus 5x plus 6. The 5x is already prime. It will not factor. Now, if we look at the denominator, what two values? We know that it's got a leading coefficient of 1, so we know that we're going to end up with two binomials. And we know the leading term in both is going to be x. Both of the x term and the constant are being added, so we know it's going to be plus and plus. Now, what two values add to 6, or excuse me, multiply to 6? Their product is 6, and their sum is 5. Well, that would be 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So now we have that one factored. Now let's look to our second term, x squared minus 4. That is a difference of squares, x squared and 2 squared. So that's going to be x minus 2 times x plus 2. And then the 10x, again, is already factored. It's already prime. So now we multiply the numerators and multiply the denominators. That gives us 5x times x minus 2 times x plus 2 over 10x times x plus 2 times x plus 3. So now we can cancel all of the common factors. We can divide out the common factors. Technically, I could go ahead and write this, and I'll go ahead and do that in an extra step, just to simplify things. For when we cancel, 5x times x minus 2 times x plus 2 over 10x, we could write down its factorization to make things a little bit easier. So let's factor out a 2, which is going to leave us with 5x times x plus 2 times x plus 3. So now we can cancel like factors, common factors in the numerator and denominator. Well, we have 5x and 5x, and we have x plus 2 and x plus 2. And what does that leave us with? That leaves us with x minus 2 in our numerator, and then 2 times x plus 3 in our denominator. And then technically we should note that because of all of these factors, let's look back to 10x, x plus 2, and x plus 3 when we have the factored form of our multiplication before canceling. So that means that x cannot equal 0, because then that would make 10x 0. X cannot equal negative 2 or negative 3, because negative 2 plus 2 is 0, and negative 3 plus 3 is 0. So x cannot equal negative 2, and x cannot equal negative 3. And there is the product of our original rational expressions that we were given. 5x over x squared plus 5x plus 6 times x squared minus 4 over 10x equals x minus 2 over 2 times x plus 3. And we got there by factoring the numerators and denominators of each, multiplying the numerators, multiplying the denominators, which gave us our second row here, and then canceling like terms, or canceling common factors in the numerator and denominator. And then, even though they're not asking for it, because technically it's what we should do, I'm still writing out what x cannot equal. And that's our factored and simplified form of our multiplication of these two rational expressions that we started with.